during sessions. The VLAN to VXLAN VNI mapping is configured under the Edit VLANs hierarchy. Once a VLAN to VNI mapping is performed and a local interface is configured with the corresponding VLAN, the device creates a local VTEP interface. Some Juniper devices show these in the local:/VXLAN.inet.0 routing table. Some devices do not deploy a :VXLAN.inet.0 routing table, using the inet.0 routing table instead for recursive lookups. The local VNI is then advertised to the remote peers, and the local device is advertised as a Layer 2 gateway to reach the VNI. To advertise an EVPN route, a device must have all of the required parameters for that route. The Edit protocol's EVPN hierarchy defines the required EVPN information, including the encapsulation type and the VNIs, which are part of the virtual switch instance. The example shows the encapsulation set to VXLAN. If not specified, the default encapsulation is MPLS. You can see the extended VNI list set to all in this output. This means it will include all VNI created on this device in the primary virtual switch, since that is the instance you're configuring. When creating multiple tenant environments using routing instances, you will set the extended VNI list in each routing instance to include only the VNIs relative to that tenant. The Edit Switch Options hierarchy equips the default switch table to operate an EVPN, identifies the source address of the VTEP tunnel, a unique route distinguisher that included in advertised route prefixes, and the target community that is added to the EVPN route. The VRF target specified here is always used to identify EVPN Type 1 routes. If no other configuration parameters are configured to create VRF target community strings for EVPN Type 2 and Type 3, the VRF target specified here is used. The VRF export statement adds the associated VRF target community value to the BGP updates that are sent. The VRF import policy evaluates received BGP routes, and if the VRF target community in the VRF import policy matches a community value in the route, the information from the route is imported into the local EVPN route table, and subsequently the VXLAN switching table. Matching VRF target community strings between neighbors is the catalyst for creating VXLAN tunnels. The VRF target statement under the Edit Switch Options automatically creates hidden VRF import and VRF export policies for the specified community value. If a VRF target statement is included for a VNI in the VNI option hierarchy, the VNI options VRF target statement overrides the switch options VRF target value for Type 2 and Type 3 EVPN routes. The switch options VRF target statement is still applied automatically to Type 1 EVPN routes. Note that if you do not configure the Edit protocol's EVPN VNI option stanza, then all EVPN routes are sent and accepted regardless of the remote VTEP VNI settings. When only the VRF target statement is configured, all VNIs advertised by the VTEP are tagged with the same VRF target community. Remote VTEPs that are configured with the same VRF target community accept all received routes, even if a local VNI for the advertised routes is not present. In the example, if the VRF target :65000:1 is configured on all Leaf devices, and that is the only VRF target statement configured, then the target :65000:1 community is applied to all advertised routes, and all received routes with that target will be accepted regardless of which VNIs are active on the local device. When Leaf 2 receives routes for VNI 5020, the routes will be accepted and stored in the local routing table, even though VNI 5020 is not active on Leaf 2. Best practice is to assign a unique VRF target community to each VNI within the domain. The VRF target community can be configured for each VNI. This ensures that only routes that are associated with locally active VNIs are accepted and stored in the local routing table. Because VNI to VRF target mapping should be consistent across the network, it is a simple matter of copying the same configuration to all devices as a standard, common configuration parameter. The VNI to VRF target mapping is configured under the Edit protocol's EVPN VNI options hierarchy. Configuring VRF targets for each VNI overrides the VRF target setting specified under the switch options hierarchy for EVPN Type 2 and Type 3 routes. All EVPN Type 1 routes always use the VRF target specified by the switch options hierarchy. The example also shows the extended VNI list, which includes only VNIs 5010 and 5020 in the local primary routing table. If you specify these settings within routing instance, it would control advertisements for that instance. Manually configuring all VNI to VRF target communities in a large network can become cumbersome. The Edit Switch Options VRF Target Auto parameter auto-generates a VRF target community for each VNI that becomes active on the device. When this function is used, an automatic VRF target community is derived for each active VNI on the VTEP. The community value is created using the autonomous system defined in the routing options hierarchy and the VLAN ID associated with the VNI. Remember that the VRF target community strings must match on neighboring systems for VXLAN tunnels to form. In an environment where each node has a unique AS number defined in the routing options hierarchy, the auto-generate option will not work. By default, when a local VTEP encapsulates a locally received Ethernet frame, it does not include the VLAN tag in the encapsulated frame that is sent to the remote VTEP. Additionally, when a VTEP receives a VXLAN encapsulated frame from a remote VTEP that contains a VLAN tag within the original packet, the local VTEP discards the packet. This behavior can be changed through the configuration as shown in the example. You can verify the status of BGP neighbors with the Show BGP Summary command. The BGP.EVPN.0 table holds all the overlay, which is protocol BGP family EVPN advertisements sent and received. The default switch.EVPN.0 table has all the local layer address information for interfaces configured for EVPN VXLAN, as well as any received EVPN advertisements, which match the target community list. The EVPN ribbon table is the BGP routing table that stores all received BGP routes that are of the family EVPN type. If an EVPN route is received that does not have a VRF target community that is accepted by a local VRF import policy, the route is discarded prior to being placed in the BGP. Stores all received BGP routes that are of the family EVPN type. If an EVPN route is received that does not have a VRF target community that is accepted by a local VRF import policy, the route is discarded prior to being placed in the BGP.EVPN.0 table. The EVPN route is formatted according to the parameters and values associated with the route. The examples of Type 1, Type 2, and Type 3 EVPN routes are displayed here. From the BGP.EVPN.0 route table, the EVPN routes that are accepted by policy and has matching VRF target are placed in default switch.EVPN.0 table. The example shows the primary switch table default switch.EVPN.0. This table contains all locally generated EVPN routes as well.